Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand tonight is EV software functions, and most of the diagnostics you're going to do in an electric vehicle are going to be software related, right? Because the battery's high voltage and can be dangerous to work on. There are people out there, don't get me wrong, that take them apart, they'll pull the batteries out and repair the battery, cells inside the battery and things like that. And sometimes, get corrosion in there. You might have to clean some things, but you need to do it safely and you need to do it the right way. But there's plenty of people out there that can do that as well. But there's not a lot of maintenance involved, right? Because you're not doing oil changes and stuff like that. So it's far less maintenance intense. It's like brakes, tires, and then anything that might go wrong in the electrical components. So let's talk through it. First off, let's talk about the different components in an electric vehicle. Obviously, it can vary slightly from model to model and make to make, but they're all going to have a battery because we're talking about battery electric vehicles here. They're also going to have some way to cool and slash maybe heat the battery, depends on the manufacturer as well, but they'll definitely have a way to cool the battery because they do get warm. Voltage conversion, because I need to go between all the different voltages and AC and DC and 12 volts and 200 volts and all the different voltages that might need to be in there. The regenerative braking system, which kind of is involved with the actual like the drivetrain package, the electric motor itself, and the charger, of course, because I need to be able to charge it from either a charging station or in my house. Have a charger. So as I mentioned earlier on, definitely safety first. High voltage is nothing to mess around with. You don't want to be injured. Basically, if it's bright orange underneath the vehicle, underneath the hood, probably don't mess with it unless you kind of know what you're doing, right? There is no certification in North America as far as being able to work on electric vehicles. There are courses out there that there's training companies that do put out training courses on these types of things. So definitely get yourself trained up before you go and work on these. They can be worked on just like any other car. And just remember, anything outside of the high voltage system probably runs on 12 volts, right? So a lot of the HVAC stuff and entertainment systems, seats, things like that are still run off the standard 12 volts. So you should be able to work on all that stuff. But the high voltage system may remain powered up to 10 minutes after the vehicle is shut off or disabled. Prevent serious injury or death from severe burns or electric shock. Avoid touching, cutting, opening any orange high voltage power cable or a high voltage component. Now, when I've taught through these classes before, some people have chimed in and say, yeah, I do because there's like a master disconnect most times. So they'll do like a lockout tag out, right? So they'll pull the disconnect and they'll do a lockout. And then the technician who is working on the car will have it in their pocket or something like that. Just so somebody else doesn't just randomly see, oh, this thing is out, let's plug it back in while they're working on the vehicle. Best practices would be to not do that. You would think, oh, maybe I probably shouldn't do that, but I've met people, right? So Just you want to be safe around it. You know, EVs, hybrids, they have the high voltage batteries, but they can still be worked on, right? So the battery is made up of multiple small low voltage batteries linked in series, and this gets us our high voltage, right? It results in a high DC voltage, 300, 400 or more volts. Uh, Generally speaking, you're going to see either nickel metal hydride or a lithium ion of some sort. There's all sorts of different chemistries going on out there now. But that's not really necessarily necessary to know unless you're breaking the packs apart and replacing cells and things like that. Of course, you'd want to replace them with the same one. EVs versus hybrids have very large packs. They're quite heavy. They are often structurally part of the vehicle, the underneath part of the vehicle. And you see, we even got like some chassis components connected to it in the back. And due to that, you do need special lifting equipment or lowering equipment, I guess you would say. You do need to make sure the lift that you are using, like to lift the car off the ground, is rated for the weight of the vehicle because it is going to be heavier than um, some other vehicles out there. Like if you're working on one of those Hummer EVs, I think those come in at like 9,000 pounds or something stupid like that. And it's mostly battery. So it's a big, heavy vehicle. So you got to make sure that you have sufficient lifting capacity. And then to get the battery out, this is a new tool we just introduced over the summer. And this is a battery lifting table, a battery lowering table, I guess you could also say too. It's good for other things, but mainly designed for EV applications, right? So you got it's like a little grid on there, so you can go to the mounting points, and then it's hydraulic. You know, you can lower it, raise it, move it around the shop if you need to, right? So that's a pretty handy tool if you are doing work on those types of batteries, right? Either electric or hybrid. And there's kind of a little closer look at how they do these packs, right? So that's a pack of cells mated together. So that's a cylindrical cell. They also have, some manufacturers use a pouch style battery instead, or a prismatic cell is what that would be called right there. So it just kind of depends on how it's built, how it's set up, and the battery technology that the particular OEM wants to use. So that's just kind of and they can be replaced individually. And some of the diagnosis you may do is looking at data, or there's some automated tests for that as well, and see if there's a variance, battery to battery. And if you find more than a couple tenths of a volt difference from cell to cell, you kind of figure out which cell is bad, and then you could break the pack down and replace it if you want to be that ambitious. I mean, if it's the whole battery pack in and of itself, like the whole assembly, is thousands and thousands of dollars. So it could be more affordable for the customer if that's something you were looking to get into, and break the pack down safely, obviously. And then you can just replace the individual cells. Panasonic makes most of the cells that are out there. There's other technologies coming down the pike as well. All right, so that's the battery. We also have heating and cooling for the battery, like I said. They have to be cooled to maximize performance in life. They charge best under a certain temperature range. Three methods are used. I don't think too much passive air cooling on a full EV. On a hybrid, there is. But passive air cooling, active air cooling, where it has a big, blower motor that blows over it. I'd say probably less involved in a full EV as well. It's liquid cooling, I think, is where most of them are at, just to cool the battery packs. Now, I was reading a couple articles this afternoon on the adhesive makes a difference too. I was reading a couple articles on like DuPont or something like that they've come up with these new adhesives that provide better heat transfer off the battery packs and such. So the battery packs are glued on to the base, right? So that needs to be cooled. That base would need to be cooled. When they do have liquid cooling, it could also warm the battery if needed, depending on the situation, depending on outside temperature. In this case, this is one has a heater on it, or a chiller, and then there's multiple valves just kind of direct the coolant where it needs to go. Coolant must contain deionized water because we want it to be less of a conductor. Ionized water be able to conduct electricity much better. So the special coolant that they use in these systems contains deionized water. And the coolant is either warmed or chilled by a heater or chiller. It's got an electric water pump that runs off the battery. And it also would have a radiator like an internal combustion engine would. Just so it's got to dissipate that excess heat, right? So it will have a radiator somewhere, not necessarily where you'd expect it on an ICE vehicle, but it does have a radiator. The converter and inverter converts AC to DC and DC to numerous different voltages as well. Converts high voltage to 12 volts for the low voltage system if it doesn't have an auxiliary battery. Reverses the step up to charge the battery while braking as well. So a lot of conversion going on in the control unit. So here's the electronic control unit. For that, we got a high voltage junction box, high voltage battery, and battery management system. Reports all this information, brake switch, shift lever, all sorts of things it needs to do. And then it's got 12 volts and 360 volts go in there, and there's conversions that go on in there. All sorts of magic happening inside the little conversion computer. But it just directs the electricity where it needs to go and steps it up or steps it down depending on what it needs. Then we have the regenerative braking system, and some manufacturers I feel do this a little bit better than others. I know I was for sure driving a Tesla, and it was not a fan of how that went. When as soon as you left off the pedal, it would almost immediately come to a very more rapid stop than just a coast. Wasn't a big fan of that, but um, it is out there, and all of the EVs do run a regenerative braking system to gain some of that energy used when braking the vehicle back into the battery. It's not necessarily a ton, but it's something. So it transfers energy from braking to charge the battery. It uses the electric motor to brake, so basically it spins the motor in reverse, acts as a generator. And then hydraulic brakes will, of course, still be used once you get to a low enough speed where you're actually going to come to like a stop sign or something like that. You would still have the hydraulic brakes, of course. Then we have the electric motor package. Depending on the vehicle, depending on the OEM, it may very well look just like a gasoline engine that they just drop in, because there's some manufacturers that have, like the Hyundai Kona, for example. We're going to take a look at that a little bit later. But that has multiple variants. That has a full gas engine, it has a hybrid, and it has a full electric. So they just swap out whatever they need out of the engine bay, right? So it could have an engine, could have an electric motor, could have a hybrid drivetrain system as well. It's used to drive the wheels, of course, could be high AC voltage, 500 volts plus, could be. Used to drive the wheels, like I said, used to recharge the battery during regenerative braking as it spins in reverse. And most are a three-phase AC motor. So, in order for the computer to know what's going on with the motor rotationally, though, they do use a resolver. So at the end of the shaft there, it looks like the drive shaft, I guess. It's going to have the stator, which is stationary, right? And then the rotor, which is going to be like a permanent magnet. And it's going to send a signal down the wires to tell the computer where it is rotationally, whether it's spinning forwards or backwards, and how fast it's spinning and things like that. There are functional tests that you may need to do in order to reset this, relearn this once it's replaced. Here's an example here. So the traction motor itself, that's the motor. And then we have the control unit here. You can see it is three-phase electric going in there. And usually when we have three phases, much like on a three-phase fuel pump, you have the U, V, and W circuits is what they call them. So it's pairs of electromagnets. It run into pairs of electromagnets to spin the motor. And then we have the different resolvers here. Looks like 1, 2, 3, and 4, and then positive and negative. And then we have motor temp as well in there. So those are all the little sensors for the traction motor in there. So you may need to do a reset, relearn on the resolver, depending on the OEM. What's that? Oh, Hyundai Kona. There you go. Then they don't really have a transmission as such. It's kind of a all or nothing approach. It's either on or off. So it is the reduction gear is what uses to help change the motor speed and the torque, which is reduces the rotational speed on the output, which in turn increases the torque output to the wheels. So it does kind of a reduction in there, and then it sends it out, and it can vary the speeds and the torque depending on what's necessary. Because usually an electric motor, it's going or it's not going, right? It doesn't take very long to get spooled up. It's like instant torque. So instead of chirping the wheels off the thing, we need to have the reduction gear. And of course, it must be charged. Home chargers and charging stations can be used, so there's a module for the charger as well. Regenerative braking also does provide some charge in the system, and that would be loaded into the onboard charger. So in this case, we have a little schematic. We have the high voltage battery itself there. We have a quick charging port right there, which would send it through these two relays directly into the battery. Otherwise, for normal charging, like with the Shoreline, from the house, it would go through the onboard charger controller, and then it would go into the system, and it wouldn't charge it as quickly. And we have the 12-volt battery there. We have the motor, electric control unit there as well. Heater and compressor. So also one thing to note, I don't think I mentioned it in the slides, is your HVAC system is going to run off the battery. So you're going to have your AC compressor is going to be high voltage electric usually. And then the PTC heater would be electric as well. Here's just an example of what the high voltage junction block would look like, right? So we got a couple different relays in there. There's your terminal block, your interlock there, a bunch of different terminal blocks, so those can be removed, I guess. And then we have the quick charge relays, which when it's in quick charge mode, it would just click those relays over and allow that voltage to flow right into the battery there. A couple bus bars, positive, negative bus bars, and so on in that module. All right, that brings us to diagnosis. So due to the complex electronics that are within the vehicle, within the multiple modules that control it, diagnosis from the according to the manufacturer is usually with the scanner as well. It's just use the scan tool to diagnose this. Here's the data you need to look at. Here's what you need to look at here. So in this example, this is from the Hyundai Kona again. Read data and then look at the different data points that are in there. So there's your overall voltage there, and then they have max cell voltage, minimum cell voltage, and then what, if anything's failed. And then, of course, 12-volt systems can be diagnosed just like any other vehicle. So your HVAC systems, well, HVAC systems, some of it's high voltage too. So just read up on it before you work on it. You don't necessarily have to be afraid of working on them. Just make sure you're knowledgeable enough to kind of know where you're at, and you don't get injured, right? You don't want anybody getting injured when it comes to this. Same thing with component testing. We generally don't provide much guided component testing on this. On some hybrid vehicles we do. But due to the complex electronics, once again, it's usually only done with a scanner. High voltages require caution. 12-volt systems can be diagnosed like any other vehicle, so you might have a component test for that. Most high voltage systems are not suitable to test with an automotive scope because the limit of the scope is lower than what the actual voltage applied is going to be. So our scope, for example, the limit is 400 volts DC. And if you're dealing with a much higher rated voltage sometimes, that's why we have different rating multimeters, right? We have hybrid multimeters or EV multimeters. So just so you're aware of that. And that brings me to live on the tool. Let's see a few functions because it is EV scanner functions after all, right? So first one I want to do is this Mustang Mach-E. For a while, that was the only automobile that Ford was making. Seems like quite a few OEMs, at least in the States, are going back to internal combustion engines. So. And then we're going to come down, and if we're looking for things for EV, right, you normally think like, engine, transmission. Well, it doesn't have an engine. It doesn't have a transmission. It does have ABS, though, airbag, all that other stuff still needs to get worked on. ADAS stuff still needs to get worked on. AV, body controls, doors and windows. All that stuff's 12 volts. When I come down here to my hybrid and electric vehicle section, we have a few different things. So we got the electric motor itself. So if we come in there, data, let's see what kind of data we have on the electric motor. So it says like, pressures, temperatures, let's see, whether or not the brake's on, grille shutters, those are usually very common on electric vehicles and hybrids. Different codes, grille shutters again, communication, accelerator pedal. Functional tests, as far as output controls, it's going to have, this is like the coolant pump and stuff, so coolant pump A command on, engine coolant bypass valve output, engine cooling fan speed desired, and grill shutter A position. Now, obviously, we know it doesn't have an engine. Technically, it's a motor, but they just call it engine cooling fan, just to keep the naming convention the same, I guess. Then as far as special functions, since it's a Ford, it's going to have PMI, so when I replace it, I do my copy and paste of parameters. The other main module that you'll see on most EVs is going to be the battery energy control module or the battery pack control module or whatever they want to call it, but it's usually just a battery control module are going to be your keywords there. I'm just going to pull this up. As far as functional tests, special functions, battery energy control module, battery health check. So this is becoming more and more common across the different brands. It's going to give you a check. So this says this procedure should only be used for diagnosis of battery electric high voltage battery conditions as directed by specific diagnostic or repair procedure. Procedure displays the following data necessary to support replace or repair decisions and diagnosis and repair for the high voltage battery. It's going to give you the individual cell group voltages and capacities. Like I said, if there's more than a couple tenths variance from cell to cell, you probably got to replace that cell. Module temperature sensor readings, pack level, state of charge, capacity and degradation, target charging voltage code for module replacement repairs. Following conditions must be met. Ignition must be on, key on, engine off. Vehicle must not be plugged into a charger. All vehicles accessories off during the test unless otherwise instructed. So we'll continue. And then it's going to give us a bunch of different tests that we can do. So it looks like it has 10 battery modules together. So if we just go into battery health for the full cell list, it's going to give us every single cell in this battery. I'm going to scroll down with 96 cells in this particular battery pack. And then it'll give you in each individual cell voltage too. So you have your amp hour rating for the capacity, and then you have your actual voltage. Now, of course, I'm in a simulator, so these aren't going to be correct. They're usually around like 3.6 volts, something like that. 3.6. Always double check your OEM stuff for that. Then if I hit continue, it's going to bring me over here, and then I can just go in each individual pack. All right, so it looks like they're in packs of 8. So that technically gives me only 80, but that's a simulator thing as well. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So voltages, capacities, things like that. So that's a nice little test for that. And then the rest of them, mainly codes and data. But we do have this, I believe it's in here. Secondary OBD control module A. So OBD, not like OBD2, like onboard diagnostics, right? Which is technically what OBD stands for, OBD2. But there are some output controls you can have, like battery charger cord lock requests. So that's to lock and unlock the cord. I think there's a B or C. I guess we'll find out. I'll go into B. No, that one doesn't have functional test. Must be C. Control module C, I believe, had a test in there. Yeah, so that is a hybrid EV battery pack coolant control valve control circuit. So that's the battery pack, coolant control on and off output. So you can command that on and off if you're having trouble with the cooling system on the battery pack. All right, next one I want to go into, let's do this Kona. The Kona, which has a lot of stuff. And like I said, that could be a hybrid or an electric. We do give you a warning at the beginning. This one has a motor control unit for the actual electric motor and the system test that allows you to control the water pump. And as far as functional tests, force run the fan for the cooling system. Battery management system. So like I said, they call it battery management system on this one. High voltage battery health check. So this got added last year or the year before, I think. And what that does is it tells you the state of charge, state of health. And then if I hit continue, of course it fails because it's 0%. And then it's going to give you max cell voltage, minimum cell voltage, and which cell has that max and minimum cell or voltage. So you know which one to look at. And then the health check's complete. So you could print that out for a customer. Isolation breakdown detection, that's an automated test to check and make sure that the isolation between the packs has not worn out. State of charge calibration and state of health calibration. So those need to be done after the battery is replaced. Function is to calibrate state of charge value in battery management systems and a state of charge value in the replaced main battery when replacing the high voltage battery. Yes, and it's just basically just resets it back to factory. So that was both those tests, right? Yeah, functional test isn't going to give me anything. All right. And then I think nothing in there. Oh, as far as yeah, data. So this one has data that's going to give you the max cell voltage, minimum cell voltage, and then your actual voltages per cell. In this case, we got 96 again, or 90, yeah, 96, let's be over here. Right. 96 batteries in different modules. Let's see, available charge power, cell voltage deviation. That's probably one you're going to want to look at to make sure there isn't too much deviation between them. Let's see, a couple other things in there. And you could print this out too. You could do like a custom data list, or you could just print the whole thing out if you wanted to. Save it for later. Show it to a customer with that. All right, and I don't think we have any guided component tests on this. Oh, we do. But the component tests are for the 12-volt systems, like ABS, body electrical, driver aids, HVAC, and starting system, the HVAC system. Yeah, mostly blend doors and things like that. All right. And lastly, I would like to go into a BMW iX, i20. And see what we got. So once again, ABS, airbags, ADAS, AV, doors and windows. And then for the on the BMW, it doesn't look like there's a lot there because it's in like submenus. So if we go in electric motor control, then we have a bunch of other things. So we have the high voltage battery health check. So that's the state of health. We'll test the health of the high voltage battery. It's an automated test. Go through there. In this case, I can't turn the ignition on, so it's not going to work. But in real life, you turn the button on. Battery management electronics. That actually brings you into more stuff. So we got functional tests in there, special functions. Discharge the high volt battery unit up to a defined state of charge. So if you need to discharge it to 50% for some reason or what have you, would bring it down there. Determine the cell module condition for transportation, electrical assessment, and disconnect the high voltage system from power and read out reasons for prevention. Service function can be used to read out the reasons why no high voltage system switched off. Check control message is displayed after pulling the plug. So that's exciting. Combined charging unit. That'd be like a battery management system, basically. What do we got here? Open and close the radiator, activate the electric fan, service history, cooling system set in a workshop mode, fill and bleed the cooling system because that's important. You need to probably do an automated bleed. Hey, Flight Sim guy, you do that, you're going to get banned. So just so you know, on YouTube. I am not shy about that. There's 3 things we don't talk about, and that's one of them. Let's see, actuator tests. Reset the ECU. Oftentimes that is a thing that we need to do. Let's reset the ECU. Let me go in here. I think there's different functional tests on this one. Teaching in the rotor position sensor. So like I said, that rotor position sensor that we had, you might have to teach that in. I think this one just puts me in a loop though. So it communicates. Service function is used to teach the rotor position sensor after part exchange. And then teach in the rotor or in the service function. If I hit teach in, I guess I can show you. So here's everything that needs to be done. So the following conditions need to be met in order to do this test. So drive position P, high voltage system active, high voltage battery needs to be charged, charging cable needs to be unplugged, and the hood needs to be closed. So also note, I know like Volkswagen, hood needs to be open oftentimes. So you always got to check when these functional tests, these service functions, you do need to make sure that everything's within spec, right? So transmission needs to be between 0 and 55 Celsius. And then it's going to go and say, well, it's negative 37. It's not going to work. It needs to be in P, and it's not in P, and it's just going to give me a loop. Just going to give me a loop. So I think there was like one other thing in here. UWIX. No. No. All right. Let's see. And then back down to here again. Electric motor controls. Like I said, stuff's hidden in there. Electric machine electronics. I think that's pretty much the same thing we just looked at, right? Yeah, teaching in the rotor assembly. And then I think one more, electric machine electronics too, and that doesn't have any functional tests. So you can see a lot of different special functions, a lot of tests to be able to test the battery pack and test the different functionalities in there. So be not afraid, because a lot of the checks are with, the scan tool itself, and the software's in there, and there's no extra charge to use the software either. It just comes included with the software. Like some other aftermarket scan tools might charge extra for EV capabilities. I've seen it. So it's all available in there, whatever we have, OE level and all that good stuff. Now you could feasibly, okay, yeah, I'll diag your car, but if it gets to the point where I got to replace the battery, maybe I might send that down the road, or maybe, if I have all the proper equipment and get into it, then sure, yeah, do that too. Could be a new profit center for you, right? So I can't really tell you what to do, but if you're going to work on EVs, just make sure you're being safe about it, right? That's the moral of that story. And most of the work gets done with a scan tool until it comes time to actually replace the battery. And then when that happens, you can decide whether that's the right move for you, or you sublet it, right? So, like I said, there are plenty of places out there doing that. Anyways, that is EV scanner functions. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.